If you get in touch with me and say just the right combination of words, it is perfectly possible to completely derail me from whatever I was doing and get me to obsessively focus on something for a couple of weeks. A couple of weeks ago, I made a video about the wild and wacky Polish-built PZL M-15. You don't need to watch that video to understand this one. All you need to know is that the M-15 is one of the weirdest aircraft ever designed, and was built to a ridiculous set of standards demanded by the Soviet Union. A couple of days later, a viewer named Toyn got in touch with something really cool. Here it is, a satellite image of 7 M-15s at the Mielec factory back in 1982. Now, not only is this photo extremely useful to confirming some of the info in my video, as we'll discuss later, but Toyn sent it at exactly the right time, and I happen to have exactly the right skill set to do something cool with it. Okay, so first of all, let's discuss where it came from. Back in the 1970s, the US began launching the Hexagon spy satellites. These deserve their own video, but to sum it up, they used phenomenally precise optics to capture very high-resolution images of Earth. The photos were captured on physical film, which was parachuted back to Earth in special re-entry capsules. That film is now held in the United States Geological Survey archives, and is available on demand through their website. And that is the first coincidence. I've used this data before. I used to work for the British Geological Survey, and we worked closely with the USGS. I'd used this exact dataset in the past. It's amazing I'd never thought to use it for my YouTube videos. If Toyn could see the M-15s at Mielec, maybe I could find some actually being used as Cropdusters. I really wanted to find at least one doing its job, maybe as a little bit of a redemption arc. Though the M-15 was a bit daft, it would be really nice to actually see one serving its intended purpose. But how could I possibly find a tiny aircraft in this huge area over the course of a decade of photos? That'd be like searching for a hard drive in a landfill. And that is piece of good fortune number 2. I'm a data scientist. If we want to find a biblically accurate aircraft, we need to think like a biblically accurate angel and become all-seeing. I can't manually sift through these images myself, but I can make something that can, a convolutional neural net. This is actually a relatively easy problem for a CNN, as we'll see, but it's a pretty big dataset, so I needed a fair amount of computing power. Now, normally, I'd do something like this on cloud compute. That costs money and, to be honest, is more effort. I probably wouldn't have bothered if it wasn't for the third and final piece of good fortune. Quite literally the day Toyn emailed me, my new GPU arrived. So what better way to christen it than to immediately set it to work on this problem? My cat Baffies will be joining us for this build. She'd been spayed the day before, so was feeling particularly sorry for herself. That's why she has a big bald patch. Alright, let's go. If I'm honest, this is the first time I've been able to build the computer I want, not the computer I can afford, and that is very much thanks to you guys. I'll be tailoring this one for 3D rendering along with some of the data science tasks I do for my day job. And just to get ahead of anyone who's about to clown on me for buying an expensive Nvidia GPU, this isn't primarily for gaming, this is for machine learning. Unfortunately, Nvidia basically have a monopoly on ML-optimized GPUs, so I don't really have a choice. But the cost isn't really relevant, this will pay for itself, no problem. For the past 15 years, I've worked on dual boot Debian or Ubuntu and Windows machines. Frankly, it's embarrassing it's taken me this long to drop Windows completely, but I've finally done so for the usual reasons. Right, so the big question now is, will it start first time? Of course it'll start first time. Right, let's get an operating system installed on it. I went with Linux Mint for now, as I wanted to just get something up and running fast for this video. Alright, onto the dataset. USGS have a ridiculous amount of high-res data in their archive. I needed to narrow down the search area and timescale. That is where the M-15 registration data came in. I talked through this in the last video, but not only does it give us the registration and retirement date of all the production aircraft, but it also gives a rough area of where they were sent. Now, these areas are still huge, but the documents suggest a bunch were sent to Ukraine, a bunch were sent to the North Caucasus region, and 2 were sent to Kazakhstan. My aim was to try and find at least one actively crop dusting, or at least parked on a farm. So I downloaded all the available images from these regions between 1976 and 1986. It should be noted, this is only a minority of the available data. USGS have much more available in their archive, but it's $30 per scan. Perfectly reasonable price, but that would add up if I wanted to cover the entire area, so I just took the freely available data. At the end, I had about 100 gigabytes or so of high-res TIFF images. Let's train a model. Coding up a model is easy. It's giving it decent data to train on that is the difficult part. Luckily, Toyn didn't realise it, but he gave me the key for that. Thanks to him, I knew what an M-15 looks like on a hexagon satellite image. So I took the basic template and randomised it a bit to create some example M-15s. I took about 1,128 by 128 pixel samples from hexagon images in Ukraine and North Caucasus, but these images were taken in 1973, that is before the M-15 existed. So we know none of these have an M-15 in them. Half of the images had one of my M-15 templates superimposed on it, but before doing so the template was randomly darkened, blurred, rotated, resized and some noise applied. Hopefully that gave a big data set of images that looked similar to actual satellite images in M-15. These images were the positive class. The other half of this training set was left as is. These were the negative class, images with no M-15s in them. Any data scientist watching will appreciate this is basically a dream data set, an unambiguously clear, simple object, only a few pixels in size and all grayscale but high quality images. I think this may be the most textbook image recognition I've ever worked on. Then I wrote a convolutional neural net, the architecture's here. We don't need to go into exactly how this works now, but feeding the labeled dataset into this trained it up to hopefully recognise M-15s in 128 pixel images. Now, all I had to do was split the collected data into 128 by 128 blocks and ask the trained model to tell me which ones it thought contained an M-15. There were about 24 million of these images, by the way. That's why we needed a neural net. And with that all done, let's see what we found. There is only one reasonable way to present this. So, did it find any M-15s? Yes, it did. Here are 35 of them in a holding area at Zaporizhzhia Airport in Ukraine. This image was taken in 1983. Now, though this is extremely cool to see, I can't draw any exciting conclusions from it. I imagine the aircraft were stored in regional hubs like this when not in use, where they could be serviced and maintained, and we do see other Cropduster types stored here too. So I'm not going to say they were just abandoned here because they were useless or anything. They may have been, but they may not. Here's an earlier photo taken at the same site. We only see a couple here. Now, I like to imagine some were out crop dusting when this was taken, but we also know many hadn't been delivered to Ukraine by this date. Okay, over to the North Caucasus. And another regional airport. Just the one here, but again, it's parked up at an airport. It's cool to see, but remember, I want to see one being used. Well, it took a little fine-tuning of my model, but here it is. An M-15 parked up on a farm. I think this is reasonable proof that the aircraft was indeed used practically, if only for a short while. In fact, I found another 2 in use on a nearby farm as well. So, in all, I managed to find 35 of the 45 sent to Ukraine, and 4 of the 97 sent to the North Caucasus. I found 3 fulfilling their intended role, which I consider a huge success. Finding a single M-15 would have made me happy, and I found 39 of them. Unsurprisingly, I couldn't find the 2 that were apparently sent to Kazakhstan. Now, I'm positive I missed some of them. I may have found all the visible ones in the images I had available, I may have not. But remember, there's a lot more hexagon data available for those willing to pay for the scans. There is one other potential detection, but not from my model. I'm going to get all the pronunciations wrong here, but let's just go for it. That registration data states an M-15 crashed on the Goloborodko State Farm in Harlovka district in the Poltava region. A quick search and I found the area, and then I noticed an old airstrip next to a village called Holoborodko. We have a date for the incident too, and the closest hexagon image was taken 2 months later. It isn't available for free, but I paid for it. As I release this video, it's queued for processing. If I can see an M-15 in that image or any evidence of the crash, I'll mention it in a community post. Maybe a few weeks before I receive that data, so I wasn't going to delay the entire video just for that. The model found a few other interesting things too. First of all, it was really good at finding Antonov AN-2s, the aircraft the M-15 was supposed to replace. They're everywhere. In fact, many of the ones I found were actively crop dusting when photographed. This one's really interesting as it highlights the difficulties of finding matches. The aircraft itself is unrecognisable, but we see the shadow clearly. The model must have identified the shadow in this case. There may very well be more M-15s in the dataset, but they're indecipherable from the background. If your plane is close enough to background noise, no image recognition will ever find it. Ever. It's quite literally impossible. Claude Shannon figured that out 80 years ago. I also got a lot of false positives of other Soviet light transports. This may be an AN-14 or an AN-28. It's interesting because it basically shared the same wing as the M-15, so it's unsurprising it was mistakenly classified. There's a few other false positives on screen now. But why did I feel the need to go through this? In the last video, I referred to the registration data to try and figure out how long the M-15s remained in operation. I concluded that none flew for more than 6 years, and the last one flew in 1987. The Wikipedia page for the M-15 states that very few were flying by 1995. If any were flying in 1995, that would contradict the registration data. As that data was a single source, and a single source from the USSR at that, I wanted to find something else to support it. I went and bought a copy of the source for that last sentence from Wikipedia. It's this book here. There's a picture of the Transavia air truck on the back, so we know it's a good book. And yes, it says very few, but with no supporting evidence that there were any at all flying at that point. A reason Toyn's email got me so interested is it was taken just as the last M-15 rolled off the production line. 7 were made in 1982, and 7 were visible on that image. So that provides some support to the registration data. I decided if I could find a few M-15s in the areas stated by that data, and around the times they were supposedly operating, that'd back it up further. Of course, nothing here is conclusive, but I'm now quite confident that the last M-15 flew operationally in 1987. But most importantly, they were actually used on farms. For 10 glorious years, the world had a jet-powered crop duster. And I think that is pretty cool.